Hello GATE aspirants, welcome to part 5 of GATE Classical Mechanics series. Question number 2. Which one of the following quantities is invariant under Lagrange transformation? So charge is invariant, so option B is correct. Next question. If the half-life of an elementary particle moving with speed 0.9 c in the laboratory frame is 5 into 10 to the power minus 6 seconds, then the proper lifetime is T is equal to T naught in bracket 1 upon 1 minus V square by C square. So from here T naught is equal to T into 1 minus V square by C square. T is given, which is 5 into 10 to the power minus 8 into 1 minus 0.9 square, which is 0.81. So 5 into, this is under root 0.19 into 10 to the power minus 8, which is equal to 2.18 into 10 to the power minus 8. So answer is 2.2 into 10 to the power minus 8, and answer given in the answer key is 2.1 to 2.3. Next question. Two masses m and 3m are attached to the two ends of a massless spring with force constant k. If m is 100 gram and k is 0.3 Newton per meter, then the natural angular frequency of the oscillation is. Now mu is equal to m1 m2 upon m1 plus m2, which is equal to m into 3m upon m plus 3m, which is equal to 3 by 4 of m. Omega is equal to under root k by mu, which is under root k upon 3 by 4m, which is under root 4k by 3m. So omega is under root 4. K is 0.3, 3 into mass is 100 gram, so that is 0.1 kg. So this is root 4, which is 2. So omega is 2. And answer given in the answer key is 1.99 to 2.01. Next question. The Hamilton's canonical equations of motion in terms of Poisson's brackets are. This is for Q, H, P. So for Q and P we have to check. Let us consider some function f. So df by dt is equal to dou f by dou q into we have dq by dt plus dou f by dou p. Here we have dou q by dou t. Dou f by dou p by dou t plus dou f by dou t. Where these are partial differentiations. Now dou q by dou t is dou h by dou p. So this means this is dou f by dou q, dou h by dou p, dou f by dou p, and dou p by dou t is minus of dou h by dou q. So minus dou h by dou q. Plus we have dou f by dou t. Now this is Poisson's bracket for f and h. Plus we have dou f by dou t. So this is for general function df by dt. Now if we consider dq by dt, which is equal to q dot. Now dq by dt, that it will be time independent because that is not depending on time. So this will be equal to qh only. And dp by dt is equal to p dot, and that will be equal to ph. So here option A is correct. Q dot is qh, p dot is ph. Next question. A bead of mass m can slide without friction along the massless rod kept at 45 degrees with the vertical as shown in the figure. The rod is rotating above the vertical axis with a constant angular speed omega. At any instant, r is the distance of the bead from the origin. The momentum conjugate to r is. Before that, we have to write down the corresponding Lagrange equation. So L is equal to T minus B. So that means this is half m. We have r dot square plus r square theta dot square plus r square sin square theta phi dot square minus this part is r cos theta. So mg r cos theta. Now here it is given theta is equal to pi by 4, 45 degree, and phi dot is equal to omega. So theta dot will be 0. So this is equal to L is equal to half m. Here we have r dot square. Second term is 0. From the third term, sin theta is sin pi by 4 square, which is 1 by 2. So plus 1 by 2 r square omega square minus cos theta is 1 by root 2. So 1 by root 2 mgr. This is Lagrangian equation. And momentum conjugate is PR, which is dou L by dou R dot. That is equal to half m and 2 r dot, which is m r dot. Option A is correct. Next question. A particle of mass m is in a potential given by V of r, where A and r naught are positive constants. When disturbed slightly from its stable equilibrium position, it undergoes a simple harmonic oscillation. The time period of oscillation is V of r is given. Now dou V by dou r is equal to minus 1 by r. So minus, it will be plus A r square minus A r naught square upon, here we will have 3 here, and it will be 3 r raised to 4. So 3 will cancel. So r raised to 4. And it should be equal to 0. That means A r square is equal to A r naught square. That means r is equal to plus minus r naught. Second derivative dou 2v by dou r square, that will be equal to minus 2a r cube minus plus 4a naught r naught square upon r raised to 5. Let us calculate its value at r is equal to r naught. This will be equal to minus 2a by r naught cube plus 4a naught upon r naught cube, which is equal to 2a, not a naught, 2a by r naught cube. Now time period is equal to 2 pi by omega, which is 2 pi m by k, and this value is k. So t is equal to 2 pi m, k is 2a by r naught cube. So option A is correct. Next question. A planet of mass m moves in a circular orbit of radius r naught. In the gravitational potential, V of r is minus k by r, where k is a positive constant. The total orbital angular momentum of the particle is. Now V effective is equal to L square by twice m r square minus plus this potential V of r, which is minus k by r. Let's take first derivative. So dou V by dou r is equal to minus L square m r cube minus k r square plus, and this should be equal to 0 for stable orbit. So from here we see L square upon m r cube is equal to k by r square. So L square is k m r. So L is equal to under root k m r, and this is when r is equal to the equilibrium value. So let it be r naught. So r naught is here. So option D is correct. Next question. Given that the linear transformation of a generalized coordinate q and the corresponding momentum p is canonical, the value of A is. That means dou q by dou q, dou p by dou p, minus dou q by dou p dou P by dou Q is equal to 1. So dou Q by dou Q is 1, dou P by dou P is 2, minus dou Q by dou P is 4a, and dou P by dou Q is 1. This is equal to 1. So 2 minus 4a is equal to 1. So 1 is equal to 4a. So a is equal to 1 by 4, which is 0.25. So answer is 0.25, and answer given in the answer key is 0.24 to 0.26. Next question. The Hamiltonian of a particle of mass m is given by h is equal to p square by twice m minus alpha q square by 2. Which one of the following figures describes the motion of the particle in the phase space? So we want to draw it in phase space. So h, so we need p square q square term. So this is of this sum, p square by twice m minus we have q square upon 2 by alpha, which is equal to h. So this is 1. If we take here 1, then this is 2h by alpha here. And this is hyperbola. This equation is of hyperbola. Now what will be P? So if you want to find out P, then from this equation P square will be twice mh plus m alpha q square by 2. This will be it. So this 2 will cancel here. This will be p square. Now what will be P? P will be plus or minus under root. If we take twice m common, and let us put energy here, energy E, plus we have alpha q square by 2. This will be expression for P. Now as we can see, if Q increases, then P is also increasing. And if Q is equal to 0, then we will have some non-zero value of P. So from 0, if we are starting, then as Q increases, P should increase. So that is happening in this case and in this case as well. Now, as Q is decreasing, if Q is negative, again we are taking here square. So that time always, that time as well, if Q is increasing, P is going to increase. So it will be of this type. As Q increases, P increases. So correct option is option D. So these were all the questions from classical mechanics part from GATE 2014 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.